for this story to Scotland and a bridge that nearly became an engineering catastrophe.
People did feel unsafe.
The lifespan of the bridge was a serious concern.
A crossing that no one wanted to cross.
I've heard of a bridge over troubled water, but this was a troubled bridge.
The River Forth, north of Scotland's capital, Edinburgh. In 1890, the Forth Railway Bridge was its first crossing and was heralded as a masterpiece of Victorian engineering. But with no room for vehicles or pedestrians, for over 70 years, if you didn't go by train, there was only one other, very slow way to get across. Engineer John Carson recalls.
I can remember as a boy here with my parents sitting on that south shore for 3 or 4 hours to catch a ferry over to just one of the villages on the north shore.
This all changed in 1964 when the Forth Road Suspension Bridge opened. The 2.5-kilometer long engineering marvel has two 69-centimeter thick main cables with hundreds of hanging wires to support the deck below.
The Forth Road Bridge was a huge achievement in its day. It was the longest bridge outside of the United States.
The two bridges wedded together to create an iconic impression on the Scottish landscape. But in structural terms, after just 4 decades, this honeymoon was over, as reporter Alan Roden discovered.
I was told by the people who worked there that the lifespan of the bridge was a serious concern. They told me that the bridge could be closed in as few as 10 years.
The rail bridge is still going strong after almost 130 years, but the road bridge was in trouble after just 50.
Nobody puts these bridges up and expects to get only 50 years out of them.
In 2004, the first large-scale inspection of the two main cables in the bridge's history revealed a concerning development.
There are thousands of cables in a bridge like this, and in the inspection in 2004, 22 had been found to have elements of corrosion.
They might look like single cables, but they're actually made up of over 11,500 thin wires.
22 corroded wires out of more than 11,000 might not sound like much, but it's too many to be ignored, as architectural journalist John Glenday explains.
You've got many thousands of cables all wrapped tightly together in bundles, and they're all taut tight. So unfortunately, it's not as simple as just going in and replacing individual snapped cables. The whole thing hangs together as a single entity.
Engineers needed to know what caused the corrosion. Part of the problem was how and where the main cables were constructed in the first place.
The major issue is Scotland's weather. It's very temperamental here in Scotland. As you can see behind me, we get a lot of damp, moist weather. That led to corrosion. We also get a lot of dry weather as well. It's not raining all the time in Scotland, despite what people may say. So you've got a real mixed climate here.
To make matters worse, during the entire 6 years of construction, the cables were spun together on site, exposed to the elements.
The wrapping and the spinning of that went on in all sorts of conditions, so you can imagine they were built in the wet and wrapped in the wet. So effectively what happens is that corrosion sets in.
The problem was, with the two main cables under constant tension, they couldn't physically be removed for repairs. So, to detect further corrosion, engineers installed acoustic monitoring equipment using microphones along the entire length of the bridge.
What you've got is a bundle of steel wires bound very tightly together. So if something snaps in the middle of that, you can't actually see it. The only way is to hear it. So you'll have sensors which can detect the sound of the cable actually physically snapping.
So every time a strand pops, it sets off an alarm. So they can actually tell now how many were breaking.
The 2004 inspections revealed an estimated 10% loss of strength in the bridge's cables.
The 10% failure rate on a piece of critical infrastructure like the Forth Road Bridge is a high margin.
Local cab driver Julia Fredrickson remembers the community becoming worried about making the crossing.
People did feel unsafe, they were frightened to go over, and I think especially the older generation who were like, oh well, you know, what if anything happens when I'm on the bridge, not knowing how bad it was.
You know, people drive across this bridge. The idea that some of the cables that are holding their vehicle up are corroded, it's a worrying prospect for them.
Yes, Scotland's longest crossing was corroding, just 40 years after it had been built. But engineers had a plan. To stop the rot, technicians proposed a solution known as dehumidification. This had been used on similar bridges in Japan to great success.
The cables were covered and hot air was continuously pumped through, a bit like a giant hairdryer designed to remove moisture.
The rust could only thrive if the bundled cables were wet inside. Dry out the moisture and the corrosion is halted.
So the dehumidification process took around about 2 years at a cost of £8 million. It was a very innovative idea, and yes, it did actually work. It started to dry out the cables, which was a huge relief for the engineers involved in the Forth Road Bridge.
With the solution found, the Forth Road Bridge should have had a clean bill of health. However, there was another problem, which was putting a strain on much more than the cables.
When the road bridge opened, it carried around about 4 million vehicles a year. That was a lot, but it was designed for that kind of number, for a steady increase, but nothing like the massive increase that it saw.
Just 4 decades after its opening, the bridge was now carrying 6 times the amount of vehicles it was designed for.
The Forth Road Bridge had to cope with around 24 million vehicles a year, which is way more than it was ever planned to take.
To add to the bridge's already considerable load, the vehicles themselves had changed over the years.
The bridge itself was designed for 25-ton, 30-ton trucks maximum. This bridge now is taking 44-ton trucks. And the pounding that does to a structure like this is huge. So it not only exerts stress onto the cables and the hangers, but it also damages the decking, because the decking has supports in it spaced to cope with the old 30-ton lorries. It doesn't have spacing in it to cope with the new 44-ton lorries.
Despite the triumph over corrosion, by now, no amount of clever engineering could return the bridge to its former strength. So in 2011, the radical solution was to build another bridge.
This was the biggest transport infrastructure project in the whole of Scotland. It took 6 years to build. It was a phenomenal project, and in 2017, it opened to traffic.
At 210 meters tall, the £1.3 billion Queensferry crossing is the UK's tallest bridge, with a very different design to its troubled predecessor. A modern concept that spreads the load more evenly.
Here what we have is a mast. That mast basically holds up the whole of that structure from the ends of the cables there to the ends of the cables here. And it's built incrementally, one section at a time. And it's called balanced cantilever construction.
Balanced cantilever construction starts from the mast and works outwards, laying road sections on either side to maintain balance during assembly.
So effectively what's happening is all those little segments are being picked up and the load's being transferred up the mast and the weight's transferred down through the foundation.
The cables are laid in sync with the deck sections being placed and connected directly to the roadway from the mast. From the start, the cables are weatherproofed, acoustically monitored, and unlike its predecessor, any and all of the cables can easily be replaced. Architect Alan Dunlop believes the design is also a more stimulating improvement.
The thing about the cable structure is that, you know, it provides a kind of elegance and very slimness to the structure itself. So not only do they perform very well structurally, it also gives a very beautiful and look to the bridge itself. So you look as though you have a bridge which is spanning over quite a large distance with a minimum of means, and it's very light and as a consequence of that, quite beautiful.
The Scottish Government wanted this, I think, to be a landmark project, and they've got a spectacular bridge. It is absolutely fabulous.
With the traffic pressure now relieved, the old Forth Road Bridge is back in business. Sort of.
The original road bridge was reopened, but this time only to public transport, pedestrians and motorcycles.
Today, this trio of functioning crossings offers a dynamic vision of Scottish engineering.
Far from competing, I think the three bridges in context add to each other, complement each other. We see through time as well as across the Forth. We see our Victorian ancestors and the work that they achieved, and we can also be proud that we're carrying that baton forward into the present day.
Building a whole new bridge is an extreme and expensive solution, but it does mean that Scotland has a state-of-the-art bridge that will keep the country moving for years to come.
For engineers, this is bridge heaven.